All right. In this video, we're going to learn all about the sampling basics, population, and parameters. We're going to start off by discussing the three big ideas of sampling. So the first big idea of sampling is that we're going to look at a part of the whole. And later on in this section of notes, we'll talk about why it is that we aren't only looking at part of the whole instead of the entire whole for whatever population we are wanting to look at. The second thing that we are going to do is we're going to make sure that it is randomized. We'll talk about why it is that we need to randomize our samples in just a little bit. The third thing that we're going to talk about is that sample size is important. So making sure that your sample size is large enough, but also not too large. And we'll kind of talk about the paradox that is getting the right size of sample for whatever it is you're wanting to collect data on. So part one is parts of a whole. So to kind of discuss what it is that we are trying to do with this is we first need to identify what is a population. So the population is the entire group of individuals that we want information from. So maybe I was interested in the opinions of students and whether or not we should come back to school in person or whether we should stay in remote learning. So the population might be everyone at Shawnee Mission North. Or maybe if I wanted to do it for the entire district, I could think about it as being all the students in the Shawnee Mission School District. So the population is kind of dependent on what you want to measure your data from. A sample then is a smaller group of individuals which is selected from the population. So again, if I wanted information on kind of the opinions on coming back to school, if my population of interest was just the students at Shawnee Mission North, I may choose to ask everyone in this class. That would be a sample. Or maybe I would choose to ask all of the seniors this year. That would be another example of a sample. And in our next couple of sections, we'll talk about the advantages and disadvantages of the different types of samples. The third thing we need to talk about is bias. So bias is when sampling methods tend to either over or under emphasize some characteristics of the population. For an example here, maybe I'm going to switch gears. Let's consider an example where we're maybe looking for what is the most popular idea for the school's prom for this school year. So we were going to look at what themes would we want to use for this year's prom. And so maybe as my sample, I chose to sample a group of freshman students in World Regional Studies. Probably not going to be the best sample of opinions about what the school prom should be because freshmen probably are not going to prom. And so asking them wouldn't really lead to the results that we would want and probably would not be representative of what the entire population wanted as a whole. That would definitely be a form of bias. So that's the idea of part one of examining a part of a whole, is that we want information about a larger group of individuals. We're going to instead take that information from a much smaller group. And we'll talk about why it is that we are needing to do that rather than just asking everyone maybe at North what their opinions were. The second part is that we need to randomize. So here's the idea behind randomizing, is that when you have random selection, it protects us from the influences of all the features of the population by making sure that the sample looks kind of like the rest of the population. In other words, we want it to be a representative sample. And randomization is the way that we do that, is that if we randomize, the groups that we get for our samples should look similar to the entire population as a whole. To illustrate this point, on the next page, I've got some summary stats which compare two different samples of 8,000, which were drawn at random from a company's database of 3.5 million customers. So, taking a look at this data. For sample 1, you can see the mean age in years is 61.4. For sample 2 is 61.2. So these numbers very, very close to one another. For the percentage that were white or Caucasian, it was 85.12% for sample 1, 84.44% for population or sample number 2. Again, very, very close numbers. They're only off by 0.8%. Very, very small difference. Percentage of female in each group. Again, very, very close numbers. 0.4%. The mean number of children. Very, very close. 3/100ths of a number. Mean income bracket. 3.91 versus 3.88 within 3/100ths of each other. Mean wealth bracket within 4/100ths of each other. And for homeowner, we've got these two that are within one of each other. In fact, about 0.94 is the difference there. So we're talking about between sample 1 and sample 2, these look almost identical. So do we think that these samples are representative of the population of the company's customers? Well, let's think about this. Maybe rather than thinking about the fact that they look the same. If they looked different, do you think that they would be representative of the entire population as a whole? So like if the numbers were just totally different from each other, do you really think you could say that those two samples were representative of the population? And I would say probably not. If they were very much different from each other, we've got some problems because at least one of those samples has a lot of bias in it. And I don't even know which one it is because they're so different from each other. But the fact that sample 1 and sample 2 in this case look almost identical, that's actually a good thing. So do you think that these samples are representative? The answer there should be yes. And the explanation would be that the nearly identical samples would be representative of the entire population. Okay, so that takes care of part 2, which was the randomized part. The next part is part 3, which is all about sample size. So a sample size, the sample size definition is the number of individuals within the sample. Now, the question typically is, how big of a sample do we want? And usually we want for our sample size, which we usually use lowercase n to say the size of the sample, we typically want that to be at least 30. So greater than or equal to 30. Now, what if we wanted to collect data from the entire population? Well, that is something that does happen. It's called a census. So a census is when you sample every individual in a population. When you think census, think about the U.S. Census, which actually just recently happened. In fact, we're in a census year right now. So the 2020 census is ongoing. They've been collecting data for a long time at this point. They're just now starting to probably look at some very preliminary information from that data. So a census does happen. But if you think about it, this 2020 census is the most recent. Do you know when the most recent is before 2020? And if you don't, that's okay. The last one was in 2010. So if you think about that, that means that we are only taking a census of our country once every 10 years, once every decade. So for you guys, you would have been anywhere from like 6 to 8 years old the last time a census was done, which is kind of crazy to think about. So why does it not happen more often? What are some of the drawbacks of conducting a census? Well, first off, it's very time consuming. And that's part of the reason that it takes so long in between the U.S. Census is just the amount of time it takes to collect the data. The other thing is that participation is hard to come by. For anyone that has done any sort of a study, maybe for the yearbook or for the newspaper, if you've ever tried to get data from other people, even your classmates and friends, who it should just be an easy, here's the survey, fill it out. And if you think about how many times we do that each year for the newspaper, even just Shawnee Mission North or the school yearbook, there's so many people that just hit delete on their email or don't even check their email in the first place. So participation is always kind of a hard thing to do. The other thing that really kind of drives us away from conducting a census is they can be very costly. And now we're not just talking about costing us time, we're talking about costing us money. Because here's the thing, for U.S. Census, just the price of postage stamps alone to be able to send a census out, not just once, but multiple times to over 300 million people in the United States, by itself is just astronomical in terms of cost. In addition to that, you also have the people who are making the phone calls to try to get everyone to turn in the census. Plus, you have all the people on the back end, all the statisticians and people crunching numbers, and it's just an astronomical amount of money that gets spent to conduct the census. Now, that being said, it is very important. The census does all sorts of things, and I know you've seen the commercials, but from helping to fund schools to helping to create the boundaries for our politicians who are running for office, to determining the electoral college when different populations of states changes drastically. Super important that we do it, but something that can't happen all the time. So just in summary, with a couple of new ideas here for you for the end of these notes today, the population, again, reminder, is every individual we want information from. Anytime we actually collect information from the population, meaning we conduct a census of some kind, we get what's called a parameter. So a parameter is a measure of the entire population. So let's say for one of the questions on the U.S. Census Bureau, we were collecting information on the age of everyone filling it out. And we found out that the average age for everyone in the United States was 42.7 years old. That would be an example of a parameter. It came from the entire population. On the other side of things, and what we were focused on today, was this idea of sampling. So a sample is a much smaller subset of the population, meaning we're not looking at everyone, we're just looking at one piece. When we conduct a sample, we get what's called a statistic. And so a statistic is a measure of whatever sample we took. So maybe instead of measuring the average age of everyone in the entire United States, we were just going to do the average age of everyone in Johnson County. So a much smaller subset of the entire United States as a whole. And we got that average to be 43.8 years old. So a little bit different from the overall population, which isn't surprising, but also very, very close. If you think about it, those numbers would be very close to each other. That would be an example of a statistic. Okay, so hopefully after this video, you have a better understanding of what is a population versus what is a sample, and what are those kind of main ideas behind why we sample. Hopefully you also have an idea of what a census is and some of the drawbacks to doing a census. That being said, I will talk to you guys next time.